Right, so let's get started. So what is the AWS DeepRacer? So this is what you call my notes are saying an 18th of a scale. I usually don't like to use notes. I tried my best to see if I can help with basically notes. So this is AWS DeepRacer. So I came with notes. Let me open that. Let me try DeepRacer. Let's look at that. Dark mode. AWS DeepRacer is what we call it's a virtual race and autonomous. So basically, it's basically what we call autonomous racing. So instead of actually controlling your controlling your actual computer or your actual cars using buttons left right, you need to train your computer to actually, I mean your car, to actually get its way through a track. Yeah, so you guys know about F1. This is basically F1 but autonomously. So you're going to train your car to find how to train itself to run around the track without any input from a human. Yeah, so let's look at my notes again. So basically what we do, so we have two. DeepRacer occurs in two. So we have DeepRacer, you can actually buy and order DeepRacer. Let me show you that. Let me actually show you that. You can actually a deep racer Amazon. I think you can buy DeepRacer Amazon.com. Okay, sure, .com. So Amazon.com. Wow, why is it taking time? So you can actually, so you have DeepRacer. You can actually buy. So this is DeepRacer. It's an actual car which is 1/18th of scale. You can actually buy this and ship it. And then once you finish training your particular model, you can load it onto this. There are actually schematics for actually making your own track. But for this case, I'm pretty sure this particular meeting that we're going to have for AWS Community Day, it's 100% sure that we don't have this unless otherwise said by Felix. So before that, what we're going to do is we're going to race virtually for this particular one. So we're going to race virtually. We're going to train our models within the DeepRacer environment, and we're going to race them virtually there. So yeah, if you need information about this, I'll probably figure that out later and talk about it. So let's get back here. So we'll get hands-on on basically DeepRacer. So whether you end up racing on a virtual physical track or you want to start in simulated environment. Okay, my notes, I suck at these notes, so I'm just going to wing it the way I want it, the way we do it. So before we start on AWS DeepRacer, we need to learn a little bit of fundamentals about machine learning and AI. Yeah, so let's talk about a little bit of AI, machine learning. So AI basically, I don't know. Everybody here knows about AI. It's basically machines trying to mimic a human intelligence, basically. So within AI, we have subsets of AI, and one of those is what we call machine learning. And machine learning basically talks about now how do you train a machine to achieve intelligence. Yeah. So machine learning is what we're going to use. So we're basically trying to train our inanimate objects and machine to actually try to achieve some sort of human intelligence, and that is what we're going to talk about. So in machine learning, we're going to also talk about subsets of machine learning in this case, and some of those we're going to talk about. First, we're going to talk about, let's talk about supervised learning. We're going to talk about unsupervised. No, we're just mentioning this, and then we have RL, reinforcement learning. Enforcement, I believe, learning. Yeah, so these are three. So let's just look quickly into this, what they are, what they mean, and then we just get right into it. So for the record, what we're using to train our model is what we call a reinforcement learning. So let's begin with what is supervised learning. Yeah, so supervised learning in this case is basically let me use this. So this is an arrow, and then we have a model. So we want to train a model. In this case, this is a model that we need to train. So just like we say it's supervised learning, it means we have a supervisor. So we have somebody supervising our training. And who is this particular supervisor? We have labeling. So the people who work on remote tasks, you know that you're given task to actually label data. So for example, if this is a traffic stop sign, this is a traffic stop sign, somebody says stop. So if you feed enough images about traffic stop sign and you label them and say this one image is stop. So if you train that to the model and feed it enough data, when you feed another image of a stop sign, the model will automatically infer that this is also a stop sign. So you basically have labels for this, for basically two things. You can also label this is a cow, this is a dog. So when you feed it another image of a cow, it will know. If you feed it something that is not between the two, it will not know what to do with it. Basically, it will not know what to do. So within supervised learning, we use labels as So we label our data in order to train. So we can automatically infer from that unsupervised learning is also different. So unsupervised learning is basically total opposite. So if I have data, I have a bunch of data that I need to train data. So if I have this particular model, instead of actually labeling data, we allow our model to infer its own labels. So it's going to look into this sort of data, it's going to cluster it, and then it's going to find a pattern inside this data, and then it will use this particular data. It will infer, find a pattern, and then with that, it is going to give its own labels to the data. Something like we use this for something like email spam, something like email spam, because every time you want to know if an email is a spam, people do it differently all the time. So people come with new ways. So you cannot depend on supervised learning to say that this email is a spam, that is not a spam. So the model has to find its own way of classifying these two things, and that is what we call unsupervised learning. So the model has to be able to infer and find its own labels for that particular scenario. And then now when we come to reinforcement learning, and this is what you're going to use to train, reinforcement learning is different. So reinforcement learning has three things. In reinforcement learning, we have what we call an agent, we have what we call an action, environment, reward, and a state. So let's talk about what those are. So let's talk about reinforcement learning, because this is the actual real thing that we are supposed to be talking about. Reinforcement learning. So we have reinforcement learning. Let's talk about, so within reinforcement learning, the basic premise of this is that your agent knows nothing. So your agent will exist. So for example, this is an environment. We will call this an environment. So we call this an environment. So an environment is basically environment. Sorry about my spellings. I don't know. I might be too tired or something. I have no idea. So this is an environment. You're going to put an agent inside your environment, and then you're going to let the agent learn. So the agent, when you're putting it in here, it doesn't know anything. So you're going to let your agent, let's say you're going to have your agent explore stuff within this particular. It's going to explore stuff within this particular environment. Yeah. So this is our agent, for example. You know the famous phrase "fuck around and find out." Basically, that is basically what you're having up inside here. So you have your agent going, it's fucking around and finding out, basically. Yeah. So this is what you're going to use to train our model. Where the hell is that? So we have an agent action. So agent. So our agent is this. Our agent is whatever it is that we're actually training inside this. So this is our agent, and then our environment is whatever place we put it in. And now action is whatever it is going to do. So if we have an agent, we probably let it move around to start exploring this environment. Now that is basically, it's an action that it's undertaking basically. And then at any point, if this agent is here or it's here, that is each state at any particular time, the state of the agent at any particular time. And then in the end, we have what we call a reward. So in order to train our model, we need to create what we call a reward function. Yeah. So for example, if somebody, let's say somebody who comes from the US, the people in the US usually are not very up to date with a lot of cultures outside of the US. So if somebody like that goes to, let's say, a place like India, and then they do something that is out of culture, they're basically fucking around and finding out. So if they do something bad, you probably get beaten up. So if somebody beats you up, you learn that, okay, if I do this, I get beaten up, so I should not be doing it. It's the same concept you're going to work with here. So you have an agent here, and then we're going to let this explore. So you're going to have it go here, go here. So as it continues exploring, it's going to realize there are places when it goes, we are going to have a problem. It's going to get beaten up. It's a place when it goes, it's okay. So it's going to, after doing that relatively over and over again, it's going to realize that it needs to avoid going here, it needs to avoid going there. Now let's put that into our AWS. So reinforcement learning is basically what we do. We put our agent in environment and let it explore. It does not know anything, and then as it explores, it realizes, okay, if I go here, I will die. So if you go to the forest, you're dumped into the forest, you realize if I go here, we have animals here, I might die. If I go here, if I put a fire around me at night when I'm sleeping, I'm likely to chase away animals, basically. So you are learning how to survive on your own, and that is the entire concept of reinforcement learning. And then the best thing about reinforcement learning is that every time your model completes training, you can always use what you have inferred from that model, re-input it into the model again, and then to fine-tune it and make it better. So that is basically the entire concept of reinforcement learning. So now let us move that into our DeepRacer. Talk about DeepRacer using reinforcement learning. So let's talk about DeepRacer now. Deep. Okay, my spellings today are pretty stupid, but that's okay. Okay, so we have DeepRacer now. So let's use reinforcement learning into DeepRacer. So let's put let's say this. We have a track. So with the DeepRacer, we are going to start raising our things autonomously. And obviously, as we're going to race, obviously, in order for you to complete a race, what do you need to do? Number one, to complete a race, number one, should never crash. No crashing, never crash. Don't crash, ever. Don't crash. And in DeepRacer, when do you say somebody has won? So number one, that guy to have won, they are not supposed to crash. And then they're supposed to probably do the shortest time around the path, around the track. Yeah, so these are the two things. Don't crash, and then find a way to take the shortest time around the path. So when we're going to fine-tune our models, these are the two things that we're trying to achieve. We are trying to go shortest time around the path without crashing. Now, let's do this. So let's create an environment, and in this environment, our environment is going to be let me use this. Let me use this. So we want to let's create a track. Okay, let's draw that path again. Let's talk about that path again. So this is our basically track. So this is our track. I can okay, so this is our track, and we have, let's say this is our agent. So we have our agent, and our agent is a DeepRacer. Let's talk about it. So this is our DeepRacer car. In fact, let's drop that. Let me do another one. So Z. Let me use do I need to use let me use this yellow color for this particular one. I'm not very good with this. So this yellow lines, let's say this is the middle, dividing the road in the middle. So I'm not an artist, so this is the best I can do. Yeah, so this is the middle of the road. So this is our track. Let's go back. That is our track. That is our track. So that is our track. And now we have our car here. So our car. So in this case, our agent is our car. So the car is the agent in this case, and the environment is this particular track. We want to learn how to have it go around it. Yeah. And then action is whatever it takes. How is it going to go through this? That is basically action. And then we are probably looking for an outcome. So if I can do this, we can say we start here. Let's say we start from here, and then I can start from here and then I finish from there. So we go, let's say we go clockwise. We are basically going clockwise in this case. Nope. We're going clockwise. We're going probably clockwise. Okay, so we're good now. So this agent needs to find a way. So what we're going to do is we're going to let this car start moving. Then when it moves, we are going to create what we call a reward function. So we need to find what we call a reward. So what is a reward? We have already talked about. So we are going to create a set of scenarios to tell the car that, let's say for example, we're going to say something. So if the car goes beyond and crashes, we're going to deny it something. So we might say, if I want to train a dog, to be a good dog. So when it goes to poop, so if a dog poops in the right place, let's say in the toilet, I give it treats. If it goes and poops in someplace else, you deny it treats, basically. So the dog will know that every time it needs to get treat, it needs to go poop in the right place. So that you have a reward function. So you are rewarding the dog for anything good done, and you probably you don't reward it for something bad done, and that is what you're going to do. So our agent is going to start just moving anywhere on the track. Yeah, and when we say, let's say clockwise, we're going to have it move around. So if it goes and crashes here, it's going to realize we're going to deny it points, basically, and then it's going to realize, okay, I should not crash. If it comes here and crashes here again, it realizes, okay, I denied points. So it's going to realize that going to the edges is a bad idea. So it's going to try avoiding going to the edges. Then it's going to try running through, just in the middle. And then we're going to see how we're going to write that. So that is what we're going to do. We're going to let our model explore the environment, and then we're going to write a reward function for it so that it knows when it does something that we don't want it to be able to be doing. Then we're going to deduct points or add points. So if it finds that, for example, every time it is running in the middle, we give it, let's say, 5 points. Then it's going to find a way to always try staying in the middle so that it doesn't crash. And that way, when it's going around corners, it cannot drip and all that stuff. So I think that is enough information. Theory. Now we can actually get started on actually DeepRacer within AWS. So before we begin that, come on. So Amazon, AWS DeepRacer. So before you do that, just know about pricing. Yep, pricing. You need to know about pricing. So you need to know about AWS DeepRacer. Pricing should be good. So we have free tier. So you need to read the fine prints of free tier so that you know how so you don't get charged. So this is what you're going to do. To get started with this, you will receive 10 free hours to train and evaluate your models. Which reminds me, I have not talked about evaluating and training. I forgot about that. So you're going to 10 free hours. So once you get started, once you actually get into DeepRacer, you will get 10 free hours to train, and 5 gigabytes of free storage. And don't stop there during your first month. So your first month, this is enough to train your first time trial model. So this is only used for if you're going to train a time trial. That different types of model you're going to use. You're going to see that in the future. So your first time trial model, evaluate it, tune it, and then re-enter into AWS DeepRacer League. This offer is valid for 30 days after you have used the service for the first time. So once you use the first service for the first time, the countdown begins. 10 free hours for that. So when AWS is activated on AWS, free tier offer applies to the AWS account once, regardless of the number of DeepRacer specific racer profile logged in using that. Blah 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 blah, whatever. Then past that, now when you exit that, training or evaluation is going to be $3 per hour, $3.50 per hour, and then storage is going to be that per gigabyte per month. So know that so that you don't get into trouble with pricing. But then again, if most of you are here, you guys have been I've always talked about getting credits. There's so many credits are free to get. If you don't know about credits, just do AWS offers. If you're new, just go to AWS offers. Should get you credits. So to start with, the smallest one are the ramp up credits. These are $300 and they're valid for 6 months. So if you open that in a new link, you should have this. should have this. So you're going to apply first name, last name, account ID, business address, select that, company name and that stuff. You should get, if you apply that in a week, you should actually get should be able to get your $300 in credits. And then there's also the $1,000 offer, which is this. So activate. So you can do activate for $1,000. You can also do that here. You can do activate. So activate give you $1,000, and if you're running an actual startup or company, you can get up to 100K. I also did that. Those videos are up on my channel. If you're new here, I did all those videos how to get that. So you can go check them out. I don't know. I'll send link. I'll send link to those. Just go search here. I think it's something here. I'm not sure. Where are those videos? Let me see. So this is for $1,000 credits. If you want to go with that, I think I also did $300 credits. So if you go check that, I'll put that in the link. I'll put that here. Perfect. So that's enough with the Nini. So now you know about, if you're going to start this, you know where you are in terms of pricing and market. So that's good. Where are we? So I needed to talk about evaluation while I was talking about this. So once you finish training your model, you should always evaluate your model, which reminds me, I also didn't talk about. So when you're training your model, number one, always make sure if you're going to train your model and you have your data, first thing you usually always probably try make sure at least use 80% of that data. Use 80% of that data for training. It's always a good practice to use 80% of your data to train your model. Yeah, so use that 80% for training, and then the 20% you should always use the 20% for evaluation. Yeah, so you need to do that for evaluation. So what is your evaluation? After training your model, you need also a data set to help evaluate if your training was actually correct. Yeah, always have around 20% left to evaluate your model. So for example, in DeepRacer, if we have trained our model inside this particular track, yeah, so after our model has been trained and done, then we'll probably need to go into to find out how well that model does in a track that goes like this. Yeah, this. So you need to also go. So the model needs to be trained here. So one of the problems is sometimes you might do very well on training in this particular track, but when you go into, let's say, AWS, into a league which has a different track, you're going to have issues because you might have a model that has been overfitted. So let's talk about overfitting. So every time we're training a model, we aim to have a balanced model, and then sometimes you can have a balanced model that has been overfitted. Sometimes you have one that has been underfitted. Fitted. Wow. Today I have issues, but that's okay. Number one, what is a balanced model? Before we talk about a balanced model, let's talk about an overfitted model. An overfitted model happens when you overtrain your model. So when you overtrain that particular model, instead of it actually trying to infer things by itself, it's going to be now replicating the data step by step. So that if you take an overfitted model from where it was trained, from its training data, and then try to evaluate it, it's going to produce a wrong output because it was not actually learning from the data, but was copying it step by step. So always, never, when you have a model, don't overfit your model. And then an underfitted model also means that you did not train your data enough, so it's not performing well on training data. Yeah, so always aim to have a balance. A balanced model means when you train it on one track, it can go to another track and work the same well because it was actually learning. You know, that is the difference. You know, the people in school who used to, when you instead of understanding a concept, you cram. So when you go probably into an exam, or let's say you go into KCC, you realize the questions that you revised for were not the ones that came. So you stay there bamboozled because you can't do anything because you are overfitted. While if somebody was learning about concepts, or probably the concepts, he was learning about concepts. When you come in, you find, okay, questions are different, but you had the concept in head, so you simply apply that. Always aim to have a balanced model. Now, I think that is enough information. So let's dive in AWS DeepRacer now, the console. So I believe everybody here has an AWS account. So let's do that. Everyone here has an AWS account. So just go log into that. Okay, pretty much. It's taking a little bit of time to load, but that's okay. Okay. So just look for DeepRacer. Look for DeepRacer. So yeah, so it depends. If for some reason they're able to actually get us actual physical models, actual physical car, then we'll probably come again and talk about this. But we'll have to contribute, because if you guys write code, one of the things that we're going to do is tweak the reward function. The reward function is one of the things that we're going to need to tweak for us to get a better outcome. So first, so this is yours. So when you go on the left, you have the racing league. So you have AWS virtual circuit. Basically, this is AWS virtual circuit. Yeah. And then if you come here, you're going to need to set up your Racer profile. So this is a Racer profile. So you're going to give your name. You're going to call yourself whoever you want to call yourself. Give yourself whatever you want to do. So in this case, region is Middle East and Africa. That and all that. So you're going to set up your email, your Racer profile, whatever you want to call yourself. So you can go there and edit profile, call yourself whatever the hell you need to call yourself. So those are what. Then we have community races. So here are some races that you can actually participate in. So with these community races, if you're able to complete, if you're able to complete these particular races, you will go to the next. And usually every year, the top 48 people are the people who actually go to AWS reInvent to actually compete there. So we'll talk about that later when we have learned how to tune a model, basically. And then you can also create your own race. So if you want to, let's say people from this community, we want to train our own model through ourselves, which we can actually also do. We might decide to train one model by ourselves, or we can decide that each person here is going to train our model, and then everybody tunes theirs, and then we get into a race. And then whoever comes out with the best model, that is the person who is going to carry us into something else, basically. So you can create your own race and then invite people to come and actually race inside that particular race, basically. So we are done with that. So reinforcement learning. So this one basically just shows you you need to create your model, train your model, evaluate it, and then you can now join a league to see how well you have actually done. So now the first thing let's talk about our model. So this is the most important part. So now we're going to create a DeepRacer model. Yeah, we're going to create a DeepRacer model. DeepRacer model. Wait a minute. So okay, we're going to come here and create a model. Okay, so let's do now this. Let's do test model demo. So I'm going to call that description. Just give it that. Why is that taking time to load? So obviously, personally, I have an obsession with tagging my resources, especially for cost reasons and stuff. Tag keys could not be distributed, could not be cheap. So name tag, let's call deep racer one demo. I'm not sure. Okay, now you can remember when we were doing when we were basically doing when you're looking at pricing levels, we are going to get that's free for time trial. So the free one comes for only time trial. So time trial is basically we're only measuring for the edge, how fast can it move through the track against clock on a well-marked track without stationary obstacle or moving. So the urgent race is against the clock. So we have a clock that is running basically. So that is for time trial. If you want to train this on object avoidance, then basically you're introducing more variables into the track. So with that, when you have object avoidance, your reward function also needs to include if you hit a block object, we also take away some points from you, basically. And then we have head-to-head racing, where this is also introducing a lot of complexity, because now In as much as you're not supposed to get off the track, you're not supposed to crash, and it's supposed to take the shortest time possible. You're also not supposed to crash on other cars that you're actually racing. So you should know that. So let's talk about the simplest, which is a time trial. And then we have PPO and SAC. Now these are basically training algorithms, which I'm not going to talk about. I'm not going to talk about. Yeah, we have what you call PPO and SAC. You can go and do those because those are very deep. You can go and do those by yourself. So usually just take this default. Now for beginner and fast trial, you can simply go to next. But let's talk about hyperparameters because you can also tweak this specifically. So for a beginner, the only thing you should first tweak is the reward function, which you're going to see. But you can also tweak parameters, especially if you're somebody who machine learning is your forte. Like if machine learning is your thing, you can actually tweak this. So we have gradient descent batch size. So obviously, basically, this is a default to 64. The more you add, if you do 128, you're going to use more compute. Yeah, so you're going to use more compute. So if you're somebody who is actually, I'm not a machine learning expert or AI expert. I just know enough to get me started. And then we have things like I don't even know what is an epoch. Let's see what an epoch is. Epoch. Epoch in ML. Epoch in ML. See what that basically talks about. Oh, okay. So epoch is the number of times a data set passes through an algorithm. You see, so with epoch, so that basically means how many times. Basically, how many times do you want that data to pass through there? So if you want, obviously, if you want, more fine-tuned result, you're going to do more. But you also need to find a way. So this one, they only need an integer between 3 and 10. So also with epochs, there's usually a problem. If you don't tweak well, you might end up overfitting your model in this case. So always be very. Oh, okay, number of runs. Rahema said number of runs basically. And then we have learning rate. So how fast do you want your model to actually learn? That is also a big thing. So if your learning rate is going to be higher, then obviously you're going to use more compute, meaning your charges are going to be basically higher. And then entropy. Entropy is what you call what uncertainties are you introducing. So the higher the entropy, the higher the chaos. Yeah. So it means you're introducing more variables. So if you have a higher entropy, then you're working with different data points and more variables. More things can go wrong. But if you have a higher entropy, because more things can go wrong, when you train your model on a higher entropy, it means it can also it can also adjust for uncertainties. So more things can go wrong during training, but if you're training it on more things that can go wrong, it means if things do go wrong, it can actually react better to those things. And then we have loss types and those. So number of experience episode between each policy updating iteration, that is between that 5 and 100. So yeah, so these are things that we'll come back to now when we're trying to fine tune our model well. So we go to next. So we're going to talk about continuous action space. It basically works. And then we have steering angle. So steering angle left, right goes between -30 to 30 basically. So this usually works well, especially if you're talking about the actual model when you're doing calibration on the actual physical car talk. So I'll leave those at default. Steering is between 30, values 30, range -30. That should be okay. Then you can talk about speed. What is the minimum speed you want? So you can actually accelerate how fast you want it to go. You can say minimum speed is 1. Then we can talk about maximum speed is, let's say, 3. Wow, that's a lot. Let me do maximum speed is 2.5. You can also leave those as default, basically. And then you just go to next. Now you're going to pick which car you want. So by default, you get the original DeepRacer, this one. But I got to customize mine, and mine has a LiDAR sensor. So LiDAR sensor is better because LiDAR sensor can track objects. Even, this is your camera. So this is a camera, a 4 megapixel camera that it uses to check. So the camera is tuned in such a way, it usually only does, it only sees things in black and white. So basically the track needs to be very contrasty. But the thing is, sometimes you might have your camera cannot capture the full essence of your environment. So if you have a LiDAR sensor, it's better because LiDAR sensor just uses radar to actually find position of objects. This is probably a good way, especially when you're going to use it in different environments. So for if it's raising if it's raising other other cars within this particular thing. So in this case, let's use the default, the original DeepRacer. Now this is the reward function we want to talk about. So this is how we are basically rewarding this particular car. So reward function, this is written in Python. So this is the one that most of the time we're going to be able to tweak. So we are defining a reward function here, and then we're going to read input parameters. So in this case, we have track width. So we have track width, which basically passes, so we have track width. Where was the track width? This is the track width. The track width is here. The width of the track is here. So we have the width of the track here. And then distance from center. We also have distance from center. So distance from here to here, that is distance from center, from the center of that. We have also defined that. Then we say we want to calculate 3 markers that are varying distances away from the center line. So we're going to say marker 1 is going to be 0.1 times track width. So marker 1 they're going to say is 0.1 times track width. 0.1 times track width, and then marker 2 is 0.25 times track width again, and then marker 3 is 0.5 times the track width. Yeah, so obviously this is a bigger number, this is a slightly lesser number, and then this is the smallest number. So with those 3 markers, we have already found its value. The next thing we're going to do is, now we're going to run an if else. So we say if distance from the center is less than or equal to marker 1, and marker 1 is 0.1 times track width, yeah, reward it, give it a reward of 1.0. So from the center, so marker 1 is 0.1 times track width, yeah, so give it a reward of 1.0. So this is the closest to the center. And then else, if distance from center is less than or equal to marker 2, which is 0.5 times track width, give it a reward of 0.5. Else, if distance from center is less than or equal to marker 3, which is 0.5 times track width, then reward negative this. So 0.5 times track width, it's farthest from the center. So if it's farthest from the center, then give it a reward of 0.1. So obviously the biggest reward is this 0.5 and 1. So when our agent or our car is going to be running within DeepRacer, then it's going to realize every time it is at marker 3, the farthest from our center line, it's going to get the least rewards, and every time it's closest, which is here, it's going to get 1 a reward, and then return float reward. So this is the default function. This is our default reward function that we're going to use, and then you're going to tweak. So in this case, for this class, I'm going to just show. I want us to train this. Let me see. I just want to train. Let's just do training for 5 minutes. Let's just do training for 5 minutes so that we don't take too much time. And then let's uncheck this, because this one means immediately you train it, you submit it. So we don't want to submit our model immediately. So we are going to only train this for 5 minutes, because if we do a full training. Now, if you train it for 5 minutes, we're going to have a model that is very weak, but we just need to show it, because we can't sit here for 1 hour waiting for our model to train. Everybody has things to do. So we're going to create our model. We're going to PTR through, and then now we're going to create our model. So now our model is going to start training. So we're going to let our model train now. So training. Let's see our model. So these are our models. So this is our model now. Our model is now actually training. Let's see. So when it starts to stream, I want you guys to show. It's training on TensorFlow basically. So manage tags. So it's still initializing training. So now it's basically going to start to train, and when it gets to a point, you're going to start seeing. It's going to give as an video feed of how at the initial stages the car is going to be crashing on the edges, and then every time it crashes, it begins again, knowing that I cannot crash, and then it's going to basically learn by itself. It's going to learn as it breaks. So it's basically fucking around and finding out. So let's see how that's taking a bit of time. Yeah, last time basically it's DeepRacer that actually the $6 was DeepRacer that actually took. So I'm not sure how much I'm going to get with this one. But I'm not worried because I have credit. So please go get credit. It's a great way for you to actually learn. Oh, it's taking way too much time. It's taking time. Models. It's training now. You see, it's training. So it's training. We're going to have to wait. So we're going to have to wait till it starts giving us a video feed about it. So it's 5 minutes, so we can actually sit and wait for it to train. So right now, I think it's training on some P instances in the background, something like that. So one thing I want to talk about is, as we talk about that, let's just talk about. So in this case, how do you fine tune your model? Once you train this particular model and evaluate it, deploy it to, let's say, a racing event, and you see how many times, how fast can you go. So in order to fine tune this model, you cannot fine tune the model that you've already trained. What you do is you clone. You're going to see. After this is done, it's going to give you an option to clone. So you can clone your model. Then as you clone your model, you can now define it with different parameters, with different reward functions to make it better. And then you can train that one. When it's done training, deploying it, and it gets better, you can also clone it and then tweak it and tweak it and tweak it all over again by providing input. Your inferences back into the model over and over again until you get to a time when you're sure that what. So for example, if you go to racer profile, think who is the best racer? Let me see who is so far. Who is the? Let me see. Community racers. Sure. Which is the? Let's see. Racer profile. So we have pre-season. Pre-season winter races are closed. So we can view leaderboard basically here. Can view leaderboard. This is Kenya. So whoa, bro. We have a 16:55:29. Man, that is ridiculous. So you see, the last time I trained my model, the fastest time I got around the track was 26 seconds and 83. I got 26 seconds. So right now, the fastest time in Kenya is this guy called Murigi, who has been able to get 16 seconds and 529 milliseconds. Yeah, so this is the fastest in Kenya. Fastest guy in Middle East and Africa is 10 seconds. Bruh. Then world record is 9 seconds. We have a world record of this guy has gotten 9 seconds. 9 seconds and 21 milliseconds. So that is what you are supposed to be aiming to beat. So right now in Kenya, if we go to, let's say, DeepRacer to deploy a model, this is the guy we're probably supposed to beat, because if you don't beat him, we're going to lose, because as we speak, the guy's model can do 16:5:29. So this is probably what you're going to beat. Anyway, our model, we're training only 5 minutes, so it's going to be a very shitty model. So we're going to see that, because we don't want to take too much time. Let's see if we are getting video feed. Let's see if we can get our video feed. Oh yes, so this is simulation video. Let's see a simulation video stream. Okay, so this is how it's initializing. So this is how it shows. I don't know what is happening with this guy. Maybe I should have given it a little bit more time to train. Oh yeah, you see, right, every time it runs out of the track, it starts again. It realizes that it gets an issue every time. So Why did it stop? I don't know why it's the video. Okay, the video stream is in real time, so it's a bit laggy. So you can see from here our data is, it starts, and every time it hits at the edge of the wall, it realizes it's getting less rewards. So it starts again, and that at that point it doesn't go away after that. So you see, in this case, it has an issue with the corners. So every time it gets out of the corner, it starts again to make sure it doesn't do that again. And it's going to train, and it's going to fuck around and find out like that every time till it goes all the way throughout the track, basically. So it's going to do that again. It's going to start when it goes there. It's still going to do that again. It's going to do that around the edges until it can actually do a corner, as it continues training over and over. So we only trained ours for about 5 minutes. So you can look at the graph. So 5 minutes isn't enough time to actually train this to make any difference. So basically, it's not enough time for us to train to know any difference. So it's not enough time, but it was just basically introduction. So now we basically know what we need to be doing to be able to train that model. So now I'm hoping that when Felix talks about what we're going to do next week, we can actually sit around and come and sit down and find out. You can start looking at, let me see, let me look at the reward function. I can paste it, and then you guys can find out if you can try and tweak it better, make it better. That. So basically that is what you're going to have. Let's see, I think, did our model finish training? Oh, it's still training. Oh yeah, it's still training. Our model is still training. Our model is actually still training, so that's not bad. Okay. Yeah, so it will continue doing that over and over and over again until it gets better. So with our 5 minute training time, we're probably going to get, our fastest time is going to be like 50 seconds or even 100 seconds, because only 5 minutes of training is not enough to get that good. So it's going to be shitty, but okay. See, now that we're getting our best model. So this is our best model. Our best model is doing, this is the reward at 14. Let's see. To read this reward function. Okay. So we're basically looking at tangents there. It's going to do that until it can actually do a full turn, I guess. The streaming is a little bit weird, but whatever. So this is an iterative process, so it continues doing it and doing it again until it gets good at it. What's going on? Oh yeah, you see, it was able to make that turn now. Oh, that time it froze. It was actually continuing in the background, but we were not able to see because there's an issue with streaming video. That's why. So yeah, you can see it managed to get that turn. That's pretty good. Now you can see it's actually here on the track. So it has managed to go through this and this. So now it's here in the track. So it has to go through all those and get back here. Not bad. So this is the reward function. Let me copy this. So this is the reward function. I can do reward function. Where do I get that reward function? Let me have it there. Reward function. Save that. Okay, pretty much. So text. No, I don't want to text copy. I want to copy shareable link. I've sent the link. That is the reward function, so you can go check it out and see if you can find a way to tweak that better, just to get started. So there's the reward function, or you can simply find it in your AWS DeepRacer. Like that. Entropy is this 64. Loss type is Huber. We're almost done. It's 2 minutes to the end of this class. So it's just 2 minutes to the end of it. Oh, it has stopped training. So training is done for 5 minutes. Let's see how shitty how fast this can actually work. So its training is done. It's saying training completed. So when it's done training, evaluation will come. So once you basically when done training, now you want to evaluate how well does this training, this model work when we evaluate it. Let's see. So the good thing is that actually you can download your model. You can actually download your model. You can actually download your physical car model, because you can send it on a flash, and when you buy the DeepRacer model, you can download it, and then you can basically load it onto your actual physical car. So if that is something that is going to happen community day, then I'll show you how to load that. I hope they're actually going to give us the physical car. That would be actually pretty awesome. Okay, it's taking a little bit of time to stop training, so let's just wait for that. Anyway, does somebody have a question as we wait for that to stop training? Anybody?
Yeah, I have a question.
Sure.
So, what does the cost of all this training look like? For example, an hour worth of training or 5 minutes worth of training. How much are you using?
Okay, so for starters, I'm hoping if you've never used AWS DeepRacer, then AWS DeepRacer pricing. If you've never actually used DeepRacer ever before, and this is the first time you're actually doing it, then I'm pretty sure you're not even going to incur any cost, because you can do up to 10 hours of training. So you can pay with 10 hours of training. You can do this. You can actually only use 30 minutes to train your first model, and then when you clone it and when you already clone your model and now you want to fine tune it, you can do 30 minutes. 30 minutes training, 30 minutes. With 30 minutes training between each iteration of each model, 30 times 1 hour, that is 30 minutes to 1 hour. So 1 hour, that is 10 hours. So you can actually do 20 iteration training with 5 gigs for free. But it should be the first time. So if you're using a DeepRacer for the first time, it starts counting then up to for the first 1 month. So that should cost you nothing if you're doing training for 10 hours and you're not using anything more than 5 gigabytes for training your model, basically. So you can also do that once you finish training a model, and then you clone it. When you clone that model, and now you want to fine tune it and iterate it using different parameters, then you can delete the original clone so that you don't occupy any more space than you need to. Well, my internet is gone. What's up with my internet? Let me see. Something is up with my internet. Sorry, something happened with my internet. Something really did happen with my internet. Sorry. So if you're opening DeepRacer for the first time today, then you start within 1 month. You can do 10 hours free, 5 gigabytes free. So to be able to constrain within that, you can do 30-minute training each to iterate. With 30 minutes, you can do up to 20 trainings if you want to fine tune your model. And make sure that when you clone one model, for example, let's see where is our models in this case. So in this case, for example, we want to train our model. So let me see. Nice. We trained it on this. So this one is trained on this track, so it should be able to work with this. Wait a minute. So with this track, for example, first let's talk about, let's see, we've already trained. Let's evaluate this. Now let's start our evaluation. So now we start to evaluate our model. We want to see how well it can actually work. So test eval demo. So we want to eval. So time trial, and then we can do 3 trials. We want to go to a track 3 times. So with evaluation, we trained it here. We trained it on this track. We can actually, if we trained it on this track, one of the best ways to make sure your model isn't overfitted is to train it on this other track. So if you train it on this track, you can actually evaluate it on a different track, on a different set of data, basically. And then virtual race, let's not submit, let's just evaluate it first. So with evaluation now, we're going to let it go through a track 3 times, and then see how well we actually perform on that particular data set. So let's start to basically start. sure.
Now that you're evaluating your full model and you're not okay from my perspective, I can't really see what part of the model is working or not. So have you found tools that can help you know this part of the model is what's bringing an issue and stuff like that?
Oh, at which part of the model? Um, no, in this case for DeepRacer, you're just going to have to wing it. So right now we are evaluating our model on a different track, and we want to see what it's going to do. So when our evaluation the results come in, so evaluation results is going to tell you number one, how much time did you take to finish the track. Number two, did you crash at any point? If did you crash at any point before completing one, then it's going to tell you the results. Then from there you can see results. So what was the issue? So far I don't have any tools, but you're just going to basically fuck around and find out. So for example, if I found out that I crashed, then I when in my next model, when I clone to iterate, I might find maybe I was going too fast. So maybe I'm going to reduce my rate, my speed, the speed minimum. I'm going to adjust maximum minimum speed to see maybe that is fast enough. Or if it's going too slow, I can adjust it to go up and down. Basically, you're going to have to you're going to have to play around with those parameters, hyperparameters, and the values until you get a sweet spot where your model is going to basically can give you the best, basically the best output in this case. So it's still initializing, it's still training.
Have you tried any other languages to know whether there's a difference in speed?
Uh, oh, trying another language for my reward function. Like, are you
Yes, yeah.
talking about writing your reward function in a different language?
Yep.
Not really, but you can actually do. You can use Go to write your reward function. Anything you can. Your reward function, as long as it works. Yeah. So you can use anything to write your reward function. Anything. So the reward function, it's not even about execution. I'm not sure if depending on what language you use to write, if that influences your. I'm not sure about that basically. If does we know that different languages execute in different ways. So which one is faster? I'm not sure if that even influences, but yeah. Now that is literally why we are in this class. We want to sit down and find out which parts do we need to tweak to get better, which one don't we need to actually tweak. That's literally, see, questions like that is why we are basically in the class. So we're supposed to go ponder through it, probably go and do my own research, go and find a DeepRacer forum and look at those questions and try and find out how to uh, you know fine tune our model to get it better. This evaluation is taking way longer than expected, but that's okay.
And my last question.
Uh-huh.
Do you know whether we're restricted? Initially, I saw you were setting up your vehicle with, you can add on gadgets, maybe like infrared and things like that.
Yeah, you
So
can.
do you know whether for the competition you're just supposed to use a base model or we are allowed to put on those add-ons?
No, for the competition you can basically do as much as you want, especially in virtual environment. Basically, in a virtual environment you can use anything, but usually when you depending on if you have the physical model, then you have to use what you have. So for example, if the physical model you buy does not have a lidar, so it's going to be. But for your competition, any race, pick the car that you need. Do, because one of the things you also realize, sometimes you might introduce lidar and think it's better, but usually in a virtual race, having a lidar sensor introduces also weight into the equation. Yeah, so it also it might be able to look at objects and not crash upon on them, but also introducing a lidar sensor, you know how lidar sensors are usually huge, so it's going to virtually add weight to your particular agent. So that is also an issue here, basically. One thing you should know. Okay, so evaluation is done. Let's look at our evaluation. Oh, it's still evaluating. Sorry, still doing time trial. Still evaluating. Sorry, thought it had finished. So still doing that. Any other questions? As we wait, any other question?
So in your experience, what's the winning formula between one team's car and another team's car? Is it the reward function or what is it? Like
What's
what are you
pardon?
competing
I didn't. I
against?
didn't. I didn't get you well. What's them? The formula.
No, essentially, what is this competition really about? Are we trying to optimize our
Yes,
models?
yes. You're trying to we have a default model. So your work is to find and optimize a model, yeah? Find and optimize a model. You're trying to do, you're optimizing your model so that you basically be the fastest. So you want to be the first one to get around the track the fastest. So you can see the shortest time we have found in Kenya. Where was that? Where was that basically? In Kenya, where did they get that? DeepRacer, your model get started, virtual circuit. Let me see. Precision, view leaderboard. So you see, this is a leaderboard. So the entire reason for this race is that, can you optimize your model enough so that you can get the shortest time around the track without crashing your car? Because your car is doing autonomously. So that is the entire thing. So you're going to, number one, how will you do it? It depends on, can you tweak your reward function good enough to get you the most optimal path? And with things like using you, so we did hyperparameters. So you can also tweak your hyperparameters, like your learning rate, how fast do you want that to go, in terms of speed and steering angles. Can you work with all those and reward function and come up with a model that will give you the shortest time around the track without crashing? So the best people who do the shortest time, and then your model should be balanced, so that if this 16 might be 16 for one track, but if I take it to a different track, it gives us. So your model also needs to be optimized in a way that it's balanced enough that if it goes to this track A and track B and track C, it should also be able to get the most optimal time, the shortest time in that particular track. Did that answer your question?
Yes, it did. Actually, my questions are more for the audience, so I'm hoping everyone
Oh,
has
okay.
gotten those
Oh,
tips.
yeah,
So
yeah, yeah. I
you've answered
get that. I
them
get that.
really well.
I get that. I get that. I get that. Let's see. Let's see here. Let's see. Model. Let's see if our model is trained. It's still evaluating. Still evaluating. Oh, it's already 3:11. Okay, it's ridiculous, but that's okay. Oh, okay. Let's see. We have a streaming video here. It's going to be a little bit hard. Yeah, you see, our evaluation is going to be shitty because we only trained for about 5 minutes. So dot ca- I don't know. I deleted my previous models because I didn't want to have a lot of space to occupy and pay for them. But I would have shown you a model that was trained for 60 minutes. A model that is trained for 60 minutes is perfect. It does not crash. The only thing that you need to tweak there is how fast do you need to get to the finish line, basically. But this was only trained for 5 minutes, so obviously it's pathetic. It's going to, it's not going to do a lot. It's not going to do very very well on this data set, basically. So it's bad. Okay. Streaming race trial. Right. Skate to race complete. Oh, so that was the second race. We're looking at, this is the third race now. So we were doing 3 trial runs. So this is, we're going now to race 3 now. Let's do that. Oh, it tried. It did pretty well there. Let's go back. But you can see in evaluation, it picks up from where it broke. When you're trying to train it, you remember every time it got off the track, it would come back to start from the beginning. So evaluation is basically, it picks up from where there's a problem, and then picks up from there and continues. Okay. Data. It's going to go off track again. Yeah, this one is a little bit tricky for it because that turn is pretty tricky. I know. it's going to have a little bit of issues, especially depending on how bad. Okay, this is pathetic, shameful. I hope nobody shows up with this kind of model during Nini, because this will be embarrassment, full blown embarrassment. Not bad. Jakes. Fine, almost. You're almost there, bro. You're almost there, bro. You're almost there. Race complete. So time trial, it has evaluated completely. So time trial, okay, trial 1. Let's see results. Lab complete. It went off track 21 times, and off track penalty is 42 seconds, but it did not crash anytime. So yeah, so you see, in this case, training our model for 5 minutes, our time is 1 minute and 33 seconds. With 1 minute and 33 seconds, you might as well be the last person on Earth with that kind of time. Who's making noise? So with that, you basically, you might as well be the last you might as well be the last person on Earth with that kind of time. I sure you'll not be able to continue evaluating your model once you stop. You will need to start a new evaluation. Okay, it's cancel. Stop evaluation. Okay, I need it to. I need to stop. So yeah, so you can see this is bad. We went off track 21 times. With the model that we trained for 30 minutes, we would not even have gone off track even once. Yeah, we would have probably have around 35 seconds to go all the way through the track. So yeah, that's terrible, but whatever. So stop evaluation. Oh, this is the first trial. Okay, we are going to first trial. So we are doing 3 trial runs. Stop evaluation. It's probably going to take more time. So that basically with that we are done. We're basically done with this particular model. So actions, manage tags. So that is simulation video. So basically that's about it. Basically that's about it for this particular introduction. For this, I hope that was actually that actually makes sense, and I can stop